Okay, welcome back. This video is basically just going to be a walkthrough of this paper. So this is November 2022, paper 1, non-calculator, and we're just going to go through all of it. Alright, so starting at the beginning, the first few marks should be quite quick, they're quite short questions. So 0.3 as a fraction, that's just going to be 3/10. Or you could say 30 over 100, that's fine as well. Anything along those lines is fine. 3 squared, remember that means 3 times 3, so that's 9. Alright, number 3 is all about BIDMAS, BODMAS, whatever you want to call it. Essentially, you just got to remember that the brackets are priority, they come first. So you're actually doing 20 divided by 5, which is just 4. Okay, so just make sure you do the brackets first. A factor of 60, that's between 8 and 14. I'd probably just list all the factors of 60. Remember, that means numbers at times to make them. I normally write them in pairs, so 1 and 60, 2 and 30, 3 and 20, 4 and 15. Keep going. 5 and 12, 6 and 10, and already we've got a couple options, so I'm just going to pick one of those. So it's got to be between 8 and 14, so either I go 10 or I go 12, or yeah, so I'll go 10, why not? Alright, and that's the first page done. Alright, that's the first page. Okay, so that should be quite quick, short, sharp questions, and then we're on to the next one. Alright, so the next page. Alright, so simplifying this, the easiest thing to do is timesing can be done in any order. So it's almost like 3 times 5 times W times T. That's a much easier way of doing it, because then 3 times 5 is quite easy to do. So that's 15. And then remember with algebra, when you're just writing times W and times T, you literally just write the letters. Generally you want to do them in alphabetical order, but it doesn't matter. No one really cares at the end of the day. You'll get the mark if you put WT. Alright, so 15 TW, all good. Alright, we've got our first wordy ones. These personally are my least favourite questions because there's sometimes quite a lot to take in. Okay, so we've got Faye. She's planning a trip to the theme park, and it's for 1 adult and 2 children, so that might be quite important information to know. Ticket cost of petrol, total cost of petrol, so £23 for the petrol. The tickets, £33 per adult and £24.50 per child. We know we have 2 children going on this trip, so we will at some point need to times that number by 2. Okay, and then we're looking at the meals. £15 per adult, £10 per child. Again, there are 2 kids going on this trip, so we're going to be doubling that as well. Alright, and now it's essentially going to be a bit of addition. So we've got all our numbers. Let's not forget about the £23 up there for the petrol. We're just going to do some addition and a bit of multiplication. So if we start off, let's double the £24.50 first. So you could either do that in your head, but you might want to just write out the multiplication. Okay, so 2 times 0 is 0, 10, 8, 9. Okay, so that's £49. Okay, and then we've got 10 times 2, so that's going to be £20 for the meal. So we're essentially just going to do an addition. So we've got £23 for the petrol. We've got £33 for the adult, there's only 1 adult. For the 2 children, it's £49. 15 for the adult, and then 20 because there's 2 children. And then we're just going to add all of that up. Okay, 3 plus 3 is 6, plus 9 is 15, plus 5 is 20. 2 plus 3 is 5, plus 4 is 9, plus 1 is 10, 11, 12, 13, 14. Okay, so that is her spending. So she spends £140. She starts with £200, so we're just going to do 200, subtract that 140. You don't really need to do them. Probably won't need to do a column multiplication for this, because you will just get £60 left over. And that goes in there. Alright, so with these wordy ones, I'd recommend if you've got a highlighter or something, just some way to annotate it, because that makes it a lot easier in the long run. Alright, onwards and upwards. Okay, list of 8 letters, and we're being asked to write down the mode. Now, mode, there's lots of different averages, alright? Now, we've been given letters here. A lot of the averages involve adding up or taking away, like the range does, the mean does. So it's really between mode and median, okay, because it's not going to ask you the range, because you can't subtract A, take away B, and get any number. So mode, what you need to know to answer this question is mode means most common. Okay, the most common. Alright, so the letter that appears the most, well, I can see that that is the letter A. There are way more A's. There are 5 A's, in fact, compared to the other letters. Okay, if you weren't sure, and you accidentally, getting mixed up with median, odds are the median will be A as well, because if you put them in a kind of order, it wouldn't be an obvious order to write, if I'm honest, because how do you know which way you want to write it? But anyway, A, I'm waffling. One of the 8 letters is going to be picked at random. On the probability scale, mark with a cross, the probability will be B. Okay, so we're going to look at, so there's 8 letters, so it's going to be out of 8. All right, and then how many B's are there? There are 2 B's. Now, 2 out of 8 is a little bit tricky to work out what that would be. However, you can write it as a quarter instead. So write it over 4, that's 1 quarter. And we can mark 1 quarter on the scale because it will be halfway between 0 and a half. So it's going to go in here. Okay, so another one there. Probability, the letter will be C. Honestly, probability is easier than it looks. You just got to look at how many C's are there. Oh, there's 1. How many letters are there? Oh, there are 8. 1 out of 8. Sorry, that was a terrible 8. All right, 1/8. Just write as a fraction, honestly. Unless it asks for a percentage or a decimal, just write it as a fraction. You're less likely to make a mistake. It's easier to write. All right, we've got some algebra coming up. Love a bit of algebra. All right, this one step. You're thinking something take away 3 is 4. Okay, something take away 3 is 4. You might already have worked out it's 7, but if you want a consistent method for doing these questions, you want only it to be m equals, that's the aim. You've solved it once you get m equals. So this minus 3 is got to go. We've got to get rid of it. So the only way to get rid of it is to plus the 3. Because if you do minus 3 plus 3, that becomes 0. So it's like the left-hand side, the 3 goes away. See you later. But if you do it to the left, you've got to do it to the right. So we've got 4 plus 3 on the right. Quite straightforward. That's just 7. That's it. Alright, nothing more than that. Okay, so on that one, m is equal to 7. Okay. Next one's a bit cheeky. It's worth 2, so you're thinking I've got to do 2 things here. It's not going to be super nice. Unusual kind of question, if I'm honest. I don't see many of these. But it's asking us to solve this. So again, our aim of the game is to get n equals this time. Different letter, so we're going to be looking for it like that. But we need to do something called collecting your like terms first. So if you've got a 3n plus, this is a 1n here. I know there's no 1 there, but essentially that's what it means. Okay, 3 plus 1, that's just 4n is equal to 24. Now remember, 4n means 4 times by n. And like last time, we added, because that was the opposite of taking away. We're going to do the opposite of times in, which is dividing. So we're going to divide it by 4. Once you divide it by 4, you can cross it off there, it's gone. And you just need to actually do 24 divided by 4. So if you do your 4 times table, 4, 8, 12, 16, 20, 24, that was 6. So n is equal to 6. And we're on to the next one. Okay, number 9. We are now finding the value of y. Okay, so what that means is we're looking for a number. And there's only one fact we need here. And it's actually going to be the reason for your answers, part B. Okay, angles on a circle or around a circle add up, or sum, if you want to use a fancy word, to 360 degrees. Okay, so to work out what y is, we're going to be doing 360 take away 70. That will give us our answer. Alright, it's quite a big angle. So we're going to get 290 degrees. Okay, so when it says give a reason for your answer, all you need to say is angles. Now you want to say around a point really. Probably not best to put it around in a circle. I'd go for around a point. Around a point, which is basically saying around a circle, let's be honest. Add up to, or sum to, add up to 360 degrees. Okay, and if you want to really make it super clear, so y equals 360 minus 70, which equals 290. That would be a lovely, lovely answer. Alright, that's number 9. Okay, we're at double digits now, number 10. A shop sells jars of coffee, it's another wordy one. Each jar of coffee costs £4, so let's highlight that. So one jar equals £4. Okay, and Michael, our guy Michael, he has £23. Okay, so we need to work out the greatest number of jars of coffee he can buy. So the only way we're going to be able to work this out is doing some sort of division, or count up how many 4s go into 23 essentially. So if we did a division, you can only do a whole number of jars, right? So the 4 times table, well, you could write the division out properly and start doing the bus stop. We only need to find out how many whole ones, so the remainder doesn't, we can just leave it as a remainder. So how many 4s go into 2? Well, none. How many 4s go into 23? Well, that's 5. Okay, and then it would be remainder 3. Alright, well, we can't have point something of a jar anyway, so we can only get a maximum of 5 jars of coffee. Yeah, so, because that 6th jar, will be £24. We don't have £24, we have £23, so we can only go 5. Alright. In a sale on Wednesday, jars of coffee are sold at half price. Michael thinks he can now buy exactly twice the number of jars of coffee for £23. Is Michael correct? You must give a reason for your answer. There's a couple of ways you could go about doing this one. So what they're saying is on Wednesday, they're sold at half price, so they're £2 instead. So one jar equals £2. So he can now buy exactly twice the amount of coffee for £23. The easiest way to do this, to be honest, is to actually work out the division. So we've got this time, how many 2s go into 23? Well, 1 goes into 2, 2 goes into 2, sorry. And then 1, 3, remainder 1. So he can buy, Michael, he can buy 11 jars, which is actually more than double, because double would be 10. Is incorrect, as he can buy 11 jars, which is more than double the 5. Okay, which is, best way to word is more than twice the number. Okay, or you could say something along the lines of, if double 5 you get 10, we get 11, so we get more. Something like that, alright, would be fine. Okay, on to the next one. 2 triangles on a grid. B is an enlargement of triangle A. Okay, so it's got bigger. We can see it's got bigger. Write down the scale factor of the enlargement. Alright. Now, the easiest way to just find out how much bigger it's got is I'm going to get my highlighter out. Might get a thinner one. That's a bit too thick. It goes from 3 across. So it starts off as 3 across. Okay, and then if I get my highlighter out again, goes to 1, 2, 3, 4, 5, 6 across. Okay, and every length is the same going to be the same scale factor anyway, because it's just a bigger version. So it's got 2 times as big, so it's 2. Twice as big, 2 is a scale factor. On the grid, mark with a cross the centre of enlargement. Now this is one you're going to want to get your ruler out for. Okay, so once you've got your ruler, what you're going to want to do is just match up each corner and then just draw a line. Oh, sorry, I've missed. Draw a line through each of the corners so that each corners that match up. Now, it doesn't need to be like perfect, as mine will not be, but you will see, or you should start to see, there's a point where they're all crossing. Okay, now mine is not perfect, I'm not going to lie to you. Oh, apologies, I'm just trying to sort out my ruler. There we go. But I'm pretty sure that the point they're supposed to be crossing is there. So I can put my ruler away. Okay, and that's where my centre of enlargement is. It's just here. Alright, so again, all you've got to do is line up the corners, draw some lines, and wherever they all cross is your centre point. Alright. Okay, we've got 2 parallelograms on the grid, and we've got to draw the mirror line. Now, this one's a little bit tricky, I would say. Okay, what I'm actually doing here, and what I would actually recommend you did if you had this in the exam, is turn it round. Because I feel like I can see this, like this diagonal here, going all the way through. That's where it looks to me that it's mirroring, because I'm going to jump that side, etc. And again, my ruler's coming back out. I shouldn't have put it away so quickly. Okay, I've got my ruler, and I'm thinking it's going to go through here, there, yeah. Alright, again, that was a terrible line, I'm doing it again. There we go. Alright, so now we should be able to look at it and it should look much better. And then it says write down the equation of the line. That's algebra's popping back out. Alright, I'm just going to get rid of my ruler because it's in my way. The equation of the mirror line. Well, actually, if you look, y and x are a bit of the same everywhere across this line. 3, 3. So actually, it's just the equation called y is equal to x, because everywhere they're the same. So we just call it y equals x. Alright, that's the end of that page. Right, let's try and get another one done. Elena spent 120 minutes at a sports centre. She played badminton for 50. Okay, she used a swimming pool for a sixth of the 120 minutes. Now, I can tell you how many minutes that is straight away. So, a swimming pool for a sixth of 120. So, that's 120 divided by 6. Alright, which is going to be 20. Because if 12 divided by 6 is 2, so 120 divided by 6 is 20. So, 20 min. So, that's actually more useful than all the waffle they've used here. Waffling. Right, and then she used the gym for 20% of the 120 minutes. So, we need to find 20%. Now, 10%. Okay, we're dividing it by 10, so that would be 12. Okay, so 20%, we're doubling that 12, so it's 24 minutes. Okay, because finding 10% of anything, you just divide it by 10, right? So that's easy to find, 12 minutes. And 20% is 2 lots of 10s added up, or doubling it, essentially. Okay, and then she spent the rest of the time in the cafe. Okay. So, we're going to add up the total amount of time. All this really is a subtraction. You're starting with 120 and you're taking off all the time. So, if you imagine you go to the sports centre and then you do the badminton for 50 minutes, take that off, and then we're going to take off the 20 minutes for the swimming, and we'll take off the 24 for the gym, and the rest of the time is cafe. A few ways we could do this. We can just start straight away by subtracting. Alright, we might as well just do that, so let's go for it. Okay, so we'll start with 120, and then we're going to subtract the 50 minutes for the badminton. Okay, so that's going to give us 70 minutes left. Okay, now we're doing 70, subtract the 20 minutes for the swimming. That gives us 50 minutes. And then we're doing the 50, subtract the 24, because it says the rest of the time will be the cafe, so this will be this subtraction here. So you go 20, you get 30, so you're left with 26 minutes. That is your answer. Okay, so you might want to say 26 mins in the cafe to make it really obvious. Alright. I didn't actually see that 26 minutes, but can't lie. Elena got to the sports centre at 1:30. She asked her friend to meet her in the cafe at 3. Did Elena get to the cafe by 3 p.m. though? That is the question. Right, well, if we're looking, she spends 26 minutes in the cafe. Alright, so that's take that off from the 2 hours. Okay, so we're taking 20, so we've got 120, and we're taking off that last 26 minutes. Okay, that will give us 94 minutes. Right, so we're starting at 1:30 p.m. 1:30, and we're adding 94 minutes. Okay, that's all we need to do. 90 minutes, to make it easier, 90 mins is 1 hour and a half. 1 hour 30, so that's bad writing. 30 mins. So 1:30 plus 90 mins equals 3 o'clock. Okay, but we're adding 94 plus the 4 mins, 3:04 p.m. So no. Okay, she did not. Elena was late for her friend. How rude. Okay, that's it. Right, a little bit long to be honest for a 1 marker, but 1 marker nonetheless in the bag. Okay, we're on to the next one. We've got a composite bar chart this time, showing the number of people living in a village. Alright, so we've been given a little key on the side. Right, so children are these grey ones, women and men. Okay, and it says write down the number of men living in the village in the year 2000. So we're looking at this 2000 one here. Okay, now we're on to the next one. It's a composite bar chart showing the number of people living in a village. Alright, they've got a little key on the side to tell us the children are the grey, the women are the lined, and the men are like the dark grey/black kind of colour. Alright, we're asked to find the number of men living in the village in the year 2000, so that's 2000. And we're only interested in the men in this case. So let's just go up to the men bit. Remember that was the darker colour. Okay, so we're just interested in the men. Looks like, so this must be the 50 mark, because it's halfway between 50 and 100, and then it looks like it goes 60, 70, 80, 90, 100. So that is going to be 60 men. Okay, then it says find the number of children living in the village in 2010. So we're looking at the children this time and 2010. So 2010 is here. And the children is at the top. However, it's not telling us that there are 210 children. That's not the case. There's 210 people. It says people, doesn't say children. So we need to find out how big this chunk at the top is. So we're going from here to here. Okay, so this, if we look at this point here, this is 150. Okay, so we're starting at 160 here. 160. We're going up to 210. Or you could just count up how many blocks. So it's 10, 20, 30, 40, 50. That might have been easier, to be honest. 50 in that little block there. So in 2010, there are 50 children. For the people living in the village in the year 2020, find the ratio of the number of children to the total number of men and women. Okay, so we're looking at the number of children. Okay, we'll look at 2020 compared to the total, and they've highlighted in bold for a reason, it must be important, of men and women. Okay, so let's find out how many children there are first, might as well. Here we go. Okay, so we've got the children, we'll go from there to there. So we're looking from 200 to, oh, where's that? So we've got 250 here, 260, 270, 280. So this block must be 80. Alright, so there's 8 kids. First thing we need to know. 80 children. So that's half the ratio done. And then to the total number of men and women. So that's everyone else. Oh, lovely. The men and women comes all the way up from 0 to 200. So there's 200. Easy. Oh, that is nice. And it doesn't say simplify it, so don't waste your time. If it's not asked you to simplify the ratio, leave it as it is. Make your life easier. Oh, that's the end of that page. Okay, we've got Jenny. What's up, Jenny? Driving from London to Swindon. Oh, Swindon's not too far. Okay, an average speed of 54 miles an hour. She drives for 1.5 hours. Work out the distance. Alright, this is where you want to think realistic. If you've done much travelling, been in cars much, if you're not sure of which way you're dividing or times in or whatnot, just think realistic. Also look at the units. So we've got 54 miles per hour. Okay, so it's 54 miles for 1 hour. And we've got for 1.5 hours. The distance is going to be in miles in a minute. Okay, but it's speed times time. Okay, so we're going to multiply these together. Alright, some ways of doing it, I would find half of 54, which is 27. Alright, you might have had to do a bus stop for that, that's absolutely fine. Half of 54 is 27. Okay, so 1.5 is a whole, is 54, plus that 27. Okay, we'll do a column multiplication just to make sure we don't make a mistake. 4 plus 7 is 11. 5 plus 2 is 7, 8. So 81. 81 miles. Quite a trek. Alexi, I'm not too sure, is using a map. The map has a scale of 1 to 25,000. Okay, on the map, the road has a length of 6 centimetres. Work out the length in kilometres of the real road. Okay, so what this means is, looking at this map, 1 centimetre on the map, on the drawing, whatever, is equivalent to 25,000 centimetres in real life. So 1 centimetre to 25,000 centimetres in real life. If you imagine something in real life can be a lot bigger than what it is on a drawing or on a map. Alright, so, but we've got 6 centimetres. Okay, so we need to multiply by 6. To make life easier, what I'm going to do is do 25 times 6. Okay, because then I'll pop the zeros back on afterwards. So 5 times 6 is 30. 6 times 2 is 12, plus the 3 is 150. So 150 plus the 3 zeros. So that's 150,000 centimetres. Now, we've got a bit of a problem in the sense that it hasn't asked us for centimetres. It's asked us in kilometres of the railroad. Because that's probably most realistic to what they would want to use if they were measuring a road. They wouldn't measure in centimetres, that would take ages. Okay, they're going to measure in kilometres. Okay, so we need to convert this to kilometres. And we'll do it in 2 stages. Alright, 2 steps. So we start with the fact that there are 100, oh sorry, it's a highlighter. There are 100 centimetres in 1 metre. Okay, we've got 150,000 centimetres. Okay, so we need to divide by 100. Okay, so we divide by 100 to get there. We can divide by 100 to get there. Alright, that'll give us in metres. So that's going to be 1500. Okay, so when you divide by 100, you're knocking off a couple of zeros, or you're moving the decimal point, would be better. Okay, so that's 1,500 metres. You also need to know that there are 1,000 metres in 1 kilometre. Sorry. So 1,500 metres is going to be 1.5 kilometres. And that's your answer. 1.5. Alright. Okay, on to the next. Okay, we've got ourselves a coordinate grid, so we've got x and y, and we've got some coordinates on it, and it's asking us for the midpoint. That might seem obvious to you what that means, it might not, but midpoint, we're just looking for the middle. Okay, the middle. The best way, the ruler's coming back out once again. Okay, the best way is to connect them up, I would say. Alright, so we draw a line between these two there. Alright, and we're looking for the midpoint, so the middle between those two. Now, it might not be obvious to you, it might be obvious to you. There's a few ways of doing it. Okay, and if we look at how far along you go, I'm just going to get rid of my ruler. Right. If you look at how far along you go in this direction, 1, 2, 3, 4, 5. So that would be 5 across. To get the midpoint, if we half that, so instead of going 5 across, we just go 2.5 across. So 1, 2.5 is going to pop us in here. Okay, and then the same for the upwards. So if you go across here, you're going 1, 2, 3, 4, 5, 6 up. Instead of going 6 up, we'll just go 3 up from where we are. So we're starting from here. Okay, 1, 2, 3. Alright, and then you end up with the midpoint of that line being there. Alright, so basically just halving how far across you go and how far up you go. And then read the coordinates of that. So it's a negative 0.5, because it's in the middle of 0 and minus 1. And it's 1 up. Alright, and that's it. Alright. At least draw a little line if you're not sure, because you'll probably pick something up for having a proper good go at it. Okay, number 16. All measurements are in centimetres. The perimeter is 52 centimetres. Work out the length DC. Okay. All we really need to know, I didn't care that it's in centimetres. All we need to know is that the perimeter is 52. Perimeter means all the edges added up. It's the journey around the shape. Okay, so what that means is we can add up all the sides. Now, the sides look horrible because they're not numbers. They're not just like 4, for example. But you still add them up. Easy peasy. Okay, so this A to B is x plus 1, plus then B to C, which is x minus 1, plus the 2x, plus 2x minus 5. Okay, that's all sides added up. Don't get thrown by these minuses in there, just write them normally as they've been written. And we've been told that equals 52. That's what it said in the question. Right, add them all up and you get 52. So let's add them up. Now we can do some stuff with these x's. Okay, they're like terms. So we've got 1x plus 1x is 2x, plus 2 more is 4x's, plus 2 more is 6x. Okay, now we've got plus 1 minus 1 is 0. Okay, so what I'm going to do is I'm going to cross them off because they make 0. And then what have we got left that we haven't done anything with? This here, minus 5. So 6x minus 5 is equal to 52. Okay, and now we're going to solve this, try and find out what x is. Alright, so first thing, like what I was saying with the equations earlier, we want x equals, right? So we're going to first get rid of this minus 5 that's chilling on the x side. It needs to go. So 6x, okay, we're going to plus the 5, because now I can say it's gone, plus the 5, 6x equals 57. Now I've got to be honest with you, I'm not impressed by their choice of numbers here. Because if I go through my 6 times table, I can get to 54, I can get 60, but I'm not getting 57. That is a horrible number to choose. I am unimpressed. Instead, what I'm going to do is I want to know DC. That's all I want to know. I don't really need to know what x is. I need to know what DC is. And DC is 2x. It's 2x. So I need to find out what 2x is. Again, it's not ideal, but I think it's easier to manage. We need to divide by 3. to get what 2x is. So we're going to divide 57 by 3. Now I know my 3's, but I don't know my 3's to 57, so the bus stop's coming out. How many 3's are in 5? 1, remainder 2. Oh, lovely. We're in the clear, don't worry, guys. How many 3's are in 27? 9. So the answer, 2x is 19 centimetres. But I honestly think that question is minging. Alright, that's horrible. So non-calculator paper, that's horrible. I apologise they've done that. But we are getting a bit further in now. Try and pick up, at least get to the stage where you get to 6x is 57. Because you're definitely at least getting 2 there. Oh, finally, some probability to save us. Alright. Only blue, green, red and yellow. Alright, so we've got blue, green, red and yellow. Yeah, nice. 100 in the bag. Ashin takes a random counter from the bag. Find the probability that it's not blue. Now this looks a bit like, well, how am I supposed to know how many greens, how many reds, how many yellows? We don't care about that really. We just want to know how many are not blue, so any of the other colours. And we can work that out because we know how many are blue. So the amount that are not blue must be 100 subtract the blue ones. That's taking out all the blue ones. So there's 70 that are not blue. Okay, so 70 out of the total number altogether, there's 100. So 70 over 100, or 7/10 if you want to feel, you know, bougie and go for a bit extra. But that's fine. 70 over 100, job done. 2 marks in the bag. I don't love that they put that table there because I think it could throw people off, but they've done it now, so there we are. Ratio of blue to green is 2 to 3. Work out the number of green counts in the bag. Alright, it's a ratio. When I think ratio, I get drawing. Okay, so we've got blue, it's 2 boxes, to green is 3 boxes. We know how many blue ones there are. Okay, blue numbers. In fact, I'm just going to move down my boxes a minute. Oh, I can't. Let me just get rid of my boxes a second. I want to draw a little bit lower down. Oh my gosh, I'm having a mare. Green. I didn't mean to. Right, okay, there we go. Okay, we know that these 2 boxes are 30 combined. Because that's all the blue ones. There's only 30 of them. But what that tells us is how much is in one box. There must be 15 in one box. And all the boxes have the same amount in. So this has 15, this has 15. Right? So this has 15. And this has 15. And this has 15. So the total number of greens was 15 plus 15 plus 15. That is 45. Right? 45. Job done. Another 2 marks in the bag. Right? 45. Alright. The number of red counters is the same as the number of yellow counters in the bag. Can Bradley be correct? Okay, so it's not is he, it's could he be? Possibly. Is there a way of making that work? First thing I'm thinking, let's take, so we start with 100. And we take off the 30 for the blue, so that's 70. Then we do 70, take away 45. What's that, 25? 25 feels right, yep, 25. Okay, so there are 25 counters left. Have a think right now. Has Bradley got a chance here? I don't think he has a chance. I think he's made an error. Why I don't think it's possible? 25 divided by 2. Go on, divide it by 2 now. You're not getting a whole number. It's not happening. Alright, you get 12 and a half. You can't have half a counter. So Bradley, unfortunately, no. You've had a blunder. No. Bradley can't be right. There are 25 counters of red and yellow. Then I'd probably say 25 divided by 2 equals 12.5, and you can't have half a counter. Not possible. Right, not going to work. Right, it's got to be a whole number. So that's a no-go. Unlucky Bradley. Better luck next time. Okay, the words are coming out again. Wordy ones. But we're good at wordy ones now, guys. We can do it. We're on question 18. We've done a few by now. 240 cans of drink on a shelf. Each can contains cola or lemonade or orange. Cola, lemonade, orange, yeah. Half the cans of lemonade and 12. Wow, this looks like a lot of work. You better get ready. Okay, so let's look at our facts. 240 cans on the shelf, and that's a ratio. Okay, so it's 5 to 3 to 2. So I'm just going to write the ratio again underneath. So for cola, not the highlighter again. Cola to lemonade to orange is 5 to 3 to 2. And they, okay, and they're 240. Okay, cool. Let's draw some boxes. Okay, so we've got 240. We're going to start with what we know before we even look at the half and 12 thing going on. We're just going to start at the beginning, alright? There were 240, and I want to work out how much each box is worth. So 240 divided by how many boxes have we got? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, easy number. Divided by 10. Okay, it's 24. So each box is 24. Crikey, running out of room. Alright, so the colas, 24 times 5. Let's work out what that is. So 5 was 20, 120. Okay, so that's the colas at the start, right? And then the lemonades, so we're doing 24 times 3, which I think is 72, but let's just check. Yeah, 72. And then the last one, 48. Right, that's our starting point now. We've worked out the individual numbers. This is a whopper, it's a 5 marker. And so the lemonade, half of the cans are gone. Okay, half are gone. Okay, so if we just look at the lemonade now. Okay, so we're doing 72 divided by 2, which is 36. They're gone. So 72 take away 36. Well, it is just 36 left. Okay, and then 12th of the oranges are gone. So we're on oranges now. So there's 48 divided by 12. Oh, that's 4 in it. Yeah, 4. Okay, so 4 removed. So 48 minus 4 is 44 left. Work out the number of cans of cola as a percentage of the total number of cans of drink remaining on the shelf. So none of the cola's gone by the looks of things. Okay, so the remaining, so we've got that 120 of cola, okay, plus the 36 of lemonade, plus the 44 of orange. That's going to be the total amount on the bottom of our fraction. We're going to have to turn it into a percentage as well. Crikey, it's a lot of work. Okay, so 6 plus 4 is 10. I'm hoping it's going to add like 200 or something. Nice. 2 plus 5. What am I about? 2 plus 3 is 5. Plus, oh, look at that. 200. Lovely. Okay, so it's going to be out of 200 on the bottom. And we're doing 100. It says cola, right? Cans of cola, yeah. So 120 over 200. Now, we can write percentages as long as they're out of 100. So to get from 200 to 100, we divide it by 2. Oh, this is so satisfying. Divide it by 2. 60 out of 100, which is 60%. Bosh. Love mark. 5 marks that, guys. 5. And to be fair, that was hard work. Have a breather, guys. That was hard work. Alright, we can do this. We can do this. Powers as a product of powers of its prime factors. A lot of words. All it's asking for is a prime factor tree. Now, I always say, if you want to start with your primes, right, and you don't know what number to start with, some primes are 2, 3, 5, 7. They're good ones to start with. I just always go for 2. If in doubt, just do 2. So, divide it by 2, and then we'll get 250. Alright, you could half it again, but you know what? I fancy doing 5 now. Doesn't matter the order you want to do it in. 5's a prime. That's going to give us 50. Okay, because 5 times 50 is 250. I'm going to do 5 again. 10. And then we've got 5 and 2. Right? 5 and 2. Then, all the ones you circle, so every time you go do each step of the branch, you circle the prime, and then you move on to the other side. So once you've circled it, that branch is ended. You don't do any more from it. So then you get 2 times 5 times 5 times 5 times 2 is your answer. Or if you want to be bougie, you say 2 squared times 5 cubed. Okay, because 2 times 2 is 2 squared, 5 times 5 is 5, 5 cubed. Alright, but I personally prefer that way. I think it's easier for you to remember. But it has asked for product of powers with prime factors, so maybe it'd be better off putting this one for this one. Okay, some fractions work, here we go. Okay, we're adding up fractions. First things first. Actually, 2 different choices here. I'd be tempted to add up the whole numbers first. 2 and the 1. 2 plus 1, so 1 plus 2 equals 3. And now we're just going to work out 3/5 plus 1/4. If this goes over 1 though, we're going to have to add that extra 1 to our total. Now remember, you can't add fractions unless the bottom numbers are the same. So we're going to make the bottom numbers the same. Okay, I'm thinking easiest way is you times them by the opposite number. So we're going to times this entire fraction by 4 and this entire fraction by 5. Okay, so times in the first one by 4, we're going to get 12/20 plus, and then times in the other fraction by 5, 5/20. Oh, we're fine. We're so fine. Okay, so we're going to get 17/20. Alright, so you just times both of them by 4 to get these, times both of them by 5 to get these, add up the top numbers, the bottom numbers don't change, so 17/20. So your answer, oh, this was so easy in the end. 3 holes, don't forget the holes, 3 holes and 17/20. Alright. That, honestly guys, you should get that right. Okay, if you're good at your fractions, it's question 20. If you're getting question 20 right, that's a very good sign for that grade 4. Right, you want to be getting this right. Okay, dividing. Show that 2 2/3 divided by 6 is 4/9. Because for now I'm just going to cover up that 4/9. Alright, we're just going to work out what that is. Right. 2 2/3 divided by 6. We're going to work that out. Now, first things first, let's make this improper. Mixed fractions are not my vibe, I'm not a huge fan of them, so let's make it improper. So, we're going to times these together and then add on the rest. Okay, so 2 times 3 is 6, plus 2 makes 8. 8/3 divided by 6. Now, I'm going to rewrite 6 as a fraction, as 6/1. Okay, I'm going to rewrite as a fraction. Now, I could go through, how this works, this method what I'm about to show you works, but I'm not going to do that. Okay, because we're just trying to get the marks here. We're going to use a method called keep, change, and flip. Okay, it's like KFC, but F and C are backwards. So we're going to keep 8/3 the same. We're not going to change it. We're going to change this divide sign to become a times sign. Okay? Then we're going to flip this fraction upside down. So it's now 1/6. Instead of 6/1, it's 1/6. And that's why I wrote 6 as 6/1. Because you can do that. Same thing. 6 divided by 1 is 6. So it's fine. Okay? And now we can times fractions in our sleep. Because you just times the 2 top numbers, you get 8. And you times the 2 bottom numbers, you get 18. 8/18. Now the answer does not say 8/18 though. If we look, it should say 4/9. But don't worry, we can fix that. This simplifies, if you half it, half it, you get 4 over 9. And now you're done. Okay, job done. You've shown it. Nice work. Alright. Simplify this. Right, this is a power of 2. Okay, this is just about power laws now. It's not very, doesn't look very nice, but it's not too bad actually. So we're going to focus with our big mass on the brackets first. Brackets comes first. So we're doing 2 to the minus 5 times 2 to the 8. Now with power laws, what that actually means is we're doing, because it's a times in, the same number, we're adding these powers together. So we're doing 2 to the minus 5 plus 8, which is 2 to the 3. That isn't the answer. Okay, because we've got to do one more thing. So actually, we've simplified the bracket really nicely. So now it's 2 to the 3 to the power of 2. Okay, and if you know your power laws, this means 2 to the 3 times 2. Okay, because it's a power to a power. So this is 2 to the power of 6. And that's it. 2 to the power of 6. Only worth 2 to be fair. Okay, we've got a horrible decimal multiplication coming up, so prepare yourself. Right, a few ways of doing it. Up to you really how you'd want to do it. You can put them in standard form and times them like that. Yeah, a few different ways of doing it really. I pretty much always, when I'm timesing decimals, I always just try and think realistically. That's not so easy because the numbers are so small already. But let's start off by just looking, sorry, I didn't do that very well. Just looking at the non-zero parts and just timesing them to get an idea of what our number's going to look like. So 32 times 4, 2 times 4 is 8, 3 times 4 is 12. So it's going to be 128 in there somewhere. It's going to be like 0.00128 or something. Okay. We are making this number here, okay, smaller, because we're timesing it by 0 point something. It's going to get smaller, okay. If it was 0.5 here, if there's a 5 here, it's going to get half the size. Okay, timesing by 0.5 is divided by half. So it's going to get half the size. So it's going to get a bit smaller than half the size. Okay, so if I'm looking at half of this, that's 0.002. Okay, but it's a bit smaller than that. It's not a million smaller, so I'm not expecting that decimal point to move further back. But that tells me where that decimal point needs to go. It's going to be 0.00128. Okay, that's all you need to do. Don't overcomplicate it. It should get about a third of the size, and that is about a third of 4, roughly. It would be like 1.28 if it was, yeah? I would just do that, honestly. Save yourself this trouble. Okay, car factory. 4 different car models, A, B, C and D. 80 people are asked which of the 4 models they would be most likely to buy. Table shows the information about the results. A, B, C and D. Work out how many B they should make. Okay, cool. So let's work out the total. So we've been told it's 80 people, actually, we knew that already. Okay, and we're looking at B really, aren't we? B, which is this middle one here. So the best way I would look at this is 15 out of 80. You know, you want about 15 out of 80 as a fraction for B. Might be able to simplify that a little bit, not massively though. And we need to know how many out of 40,000. So instead of it being out of 80, we need to be out of 40,000 as the total. Not super easy, but can we get to over, say, 400? That might be doable. So how many 8s go into 400? Well, that would be multiplying it by 5. So we're going to do 15 times 5. Let's just do some columns just to be sure. 5 5s are 25. 5 times 1 is 5 plus 2 is 7. So that's 75 over 400, right? We want it to be over 40,000. So we're timesing it again by 100. So we're going to times it by 100. So we get 7500. So they should make 7,500 of these cars. Alright? A lot of words, but we don't care about A, C or D. Literally ignore it. Pretend it's not even there. Alright? We just care about B. Okay, we've got a ratio here. Oh, interesting. Okay, so we're doing A to B to C. All we need to do for this one is to match up a letter, right? And the only letter we can match up is going to be B, because they both have B in common. So at the moment we've got A to B. This actually is quite a straightforward question, B to C. At the moment it's 1 to 3 and 6 to 5. There's a super easy way. This is honestly straightforward, quite straightforward. Making B the same. That's all we need to do, make B the same. We don't even need to do anything to this, that can chill. Okay, this B just needs to double to become a 6. So that needs to double as well to become a 2. So you can write it as 2 to 6 to 5. Okay, actually not too bad. And then A is a fraction of the total of the three numbers. So we've got 2 to 6 to 5. So to get the bottom number of that fraction, we add up all of these. Add them all up. So 2 plus 6 is 8, plus 5 is 13. And then how many of A? Well, if we look at it, it goes A, B, C. There are 2 for A. So it's 2 out of 13. Right, that's all it is. Emma, write this down. 3 numbers. This is quite tricky now. Here we go. M, N, and P. Okay, so we've been told. Okay. Alright. Alright, the way I would probably go about doing this is I'd probably think of replacing that N with how many P's. Because we want M and P, so we need N to just go, to be honest with you. So we can either replace N, so if we say N is 2M, right, N is 2M, so P equals 5N, instead of writing N, we're going to replace it with 2M. So P is equal to 5 times 2M. Okay, so P is equal to 10M. That just means that for every 1P, you need 10 M's to make the same amount. And the only tricky bit here is which way around your ratio is going to go. It's either going to be 1 to 10 or 10 to 1. Now we're going from M to P. Okay, so for every 1 M that we have, you need 10 P's. P is... Okay, and because the ratio is this way around, because if you do 10 times the 1, is what M is, you get the 10 that P is. Okay, essentially, P is bigger, okay, than M. 10 times. Yeah, so that's why the 10 is there and the 1 is there. Right, that's the only bit that gets a little bit confusing, and even I find it a little bit confusing in my brain to visualise. Alright, but that's it. Right, 1 to 10. Right, next. Crikey. Storage tank, okay, force of 10,000 newtons. First thing, we've been given a number, and it's a force. Given force. The base of the tank in contact with the ground is 4M by 2M rectangle. That is giving me something about this area here. Work out the pressure. Okay, so we've been given the force, so we don't have to do much with that. We just need to find the area. And it's a rectangle. Ever rectangle, you having a laugh? Okay, 4 by 2, times them together, 8 meters squared. Okay, so we're doing 10,000 divided by 8. That's all that question's asking you to do. 10,000 divided by 8. Not necessarily the easiest thing to do, but we can do it. A few options, a few ways of doing it. You could either actually work it out, as in like how many 8s fit into it. But what I would do is let's do 10,000 divided by 2. That's 5,000. Okay, and then half that again. That's going to give us a quarter. 2,500. And then half that one more time. That's going to give us our answer. 1250. 1250. It's just so much easier than faffing around. We're trying to do a bus stop. Okay, we're on the last page. Last bit. Solving this. Now, if this just said 5x plus 3 is greater than 18, it's easier straight away. Okay? So we're going to follow a really similar way of doing it. I'm just for a minute going to pretend that's not there. Alright? Because your first step shouldn't change anyway. It should still be the same. Okay, remember with inequalities, the sign doesn't change, so just leave the sign as it is. It's chilling. Okay, the first step is to get rid of this plus 3. So on the x side, we only want x's on this side. Okay, so it's going to be 5x on this side. And our step is to subtract 3. So we get 15 over there. And then we get 5x over whatever it was. Over 2. Alright. We can get rid of this 2 on the bottom, really. It's just annoying us. It just doesn't need to be there. So to get rid of a divide, we do the opposite. The opposite of divide is times. Double it. See you later. Okay, 5x, and then the sign, then double it, and you get 30. So we pop that in there. Nice and easy. Okay, and last step, this means 5 times x, remember? So to get rid of that 5, we need to divide by 5. And it's gone. X is greater than 6. Okay, that's all it is. Alright, which I know might seem like not easy. And it's not. It's question 26, for crying out loud. It's not easy. But it's actually quite doable if you just break down steps a little bit and don't get too thrown by this bit at the beginning. Alright. Okay, so x greater than 6. If you weren't sure also, just guess a number in there. Put the sign, put x, guess a number. What's the worst that can happen? You'll be wrong? Well, there we are. But if you get it right, could have been 3 marks in the bag at the end of a paper. Honestly, at least guess. That is one you've got to guess if you don't know. You might even just work out the number, to be honest. If you can manage to make 18 on this side, okay, whatever number for x works with that will be your answer. Okay. Last one, we're factorising a quadratic, sorry. So we're going to be looking at double brackets, is what I was trying to say. Okay. First things first, you can put your x's in straight away, right? And you can put your pluses in straight away because we've just got pluses. Okay, and what we're looking for is factors of 9. Okay, so we've got 1 and 9 and 3 and 3. And we just need to pick the pair of factors that adds up to 10. You might be thinking, oh, I know that already. 1 and 9. So x plus 1 and x plus 9. Right? That's actually quite easy but if you've practiced that a few times, you should be fine. That's quite a nice factorised question, to be honest with you, because they're both pluses, and there's not many factors of 9 to choose from. Okay, and that completes your paper. Alright, I will at some point go for paper 2 and 3, not too sure when that's going to be yet, but this is paper 1 for now. Alright.